Hello everybody. Today we are going to be talking about arc lengths on a circle. In the shortest, simplest terms, an arc length is really just a portion of the circumference of the circle. Now, to refresh our memory on what arcs are, if you remember, we had circles before spring break, and we talked about arc measurements. And so if we had this circle here, and we wanted the measurement of that arc, it would be the same as our central angle. So in this case, n degrees. The inscribed angle, remember, was half of the intercepted arc, all those things that we reviewed on Monday and Tuesday. So the arcs themselves have degree measurements, and those degree measurements are always between 0 and 360 degrees. What we're going to talk about today is arc length. So maybe we'll start with something like this. We have a circle, the radius is 10 inches. That chord we see as a diameter, and if we just wanted to find this arc length, well, we know that's a semicircle. We also know that the circumference of the whole circle is going to be 20 pi, 2 times pi times the radius. So this semicircle is really just half of the whole circle. So the length of this arc is 10 pi inches, half of the semicircle, or half of the circle, which is a semicircle. We can think of it as the half of the circle, or in short, that central angle is kind of like 180 degrees. So it's 180 over 360 of the circumference, and that circumference was 20 pi. We'll do a couple examples and you'll get this thing. So let's take a quick look. We've got a couple prepared for us already. If we take a look at this first one, we have a circle whose radius is 4 centimeters. And what we want to do now is just come up with the length of this major arc. Remember, a major arc is going to be an arc that is greater than 180 degrees. So in this case, the circumference of the whole circle, well, 2 pi r, we know the circumference is going to be 8 pi. So what fraction of the whole circle is this arc? Some of us might be looking at this right now and you're like, yo, it's 3/4. Totally. But why is it 3/4? Because this arc measures 270 degrees of the 360 degrees in the whole circle, times the 8 pi, which is the circumference of the circle. And yeah, we could do our math here, and that ends up being 6 pi. Right? 3/4 of 8 pi ends up being 6 pi, and I guess centimeters is the right unit to have here. Okay? Because we had 3/4 of the entire circle, and we got the 3/4 by taking that measurement of the arc, the degree measurement of the arc, over the 360 degrees that are in an entire circle. So let's take a look at another example now. If we have a circle with radius 6 centimeters, and we want to find the length of this arc that's intercepted by a 120 degree angle. Well, we can do that. What fraction of the whole circle is it? Well, it's going to be 120 over 360. And some people right now might be like, yo, that's going to be 1/3 of the whole circle. Totally. So 1/3 of the circumference is what we're looking for. Since we have a 6 centimeter radius, the circumference is going to be 12 pi. So we end up with 1/3 of 12 pi, or this guy would be 4 pi centimeters in length. Okay? It's really just a fraction of that circumference of the circle. So let's change it up a little bit. Let's take a look at this guy. In this one now, we don't know the radius, but we do know the arc length is 6 pi, and we know the central angle is 135 degrees, meaning the arc measurement is 135 degrees. So we know that 135 of the 360 degrees in the whole circle times the circumference of the circle will have to equal 6 pi. Okay, so we could do some algebra here. Maybe you see the pi's cancel out. So maybe you're like, oh, 270 of the 360s, because 2 times 135, times that radius is equal to 6. All of a sudden, we recognize 270 over 360. Oh, that's going to be 3/4. We start multiplying by reciprocals, whatever your strategy is, and we get that the radius here ends up being 8 units long. So knowing the arc length and the central angle, we were able to still use that concept of the arc length being a fraction of the circle to come up with the radius. All right, let's do one more. In this case now, we don't know the central angle. So the central angle, we're just calling it theta. So what fraction do we have? Well, we have theta over 360 times the circumference of the circle. Well, the radius is 9, so the circumference of the circle is 18 pi. And that's got to be equal to 5 pi. So once again, here's our equation of one variable. We could go ahead and solve this equation, and it ends up that theta is 100 degrees. And if you need to pause the video to try and get to 100 degrees, go right ahead and pause the video to try and get to 100 degrees. All right, we hope that this gave you a quick background about arc length. Don't forget that there's a couple practice problems that you don't have to turn in, but you'll have the answers to them, and make sure you're able to work through them and get to those answers. And when you're feeling comfortable, there's a Google form to fill out that is due by Thursday. And as always, if you have any questions about any of this stuff, go ahead and reach out to your teacher.